Hello everyone, today I'll show you how to run the Xiaozhi demo that we previously released on the K230. First, let's take a look at the hardware environment. Currently, Xiaozhi supports two development boards. One is the 01 Studio board and the other one is the Rusan Pi board. If you want to run it on other development boards, you will need to download the firmware and compile it yourself. So what kind of hardware do we need? First, we need a development board. In addition, we will add a front-facing camera. At the same time, we also need a touch screen. If the condition allowed, it is best to have an enclosure. We use a 3D printer to print an enclosure. The enclosure has already been open sourced. We also provide the open source link. In addition, you need a speaker. Since our board is operated via serial port, you will need to connect to a serial cable. This is the hardware required for the Rusan Pi. In fact, it is not very different. For hardware connection, there is one key point to note. In the official firmware, the camera is connected to CSI1, so we must connect the camera to CSI1. At the same time, connect the speaker and the serial port, as well as the power supply and SD card. We also need network connectivity. Depending on your situation, you can use USB to Ethernet wired networking or use the onboard Wi-Fi. As for the software environment, we provide two approaches. The quick way is to download the firmware from the official site and run it directly. The second approach is to modify the code yourself and recompile the SDK and binary files. Currently, we officially provide firmware downloads for two boards. The download links are provided here. Go to the Kendryte developer download resources, select downloads, then select software. Under miscellaneous, you will find the Xiaozhi firmware for downloads. This includes the SDK and the binary files. These are the Xiaozhi runtime files. After downloading, you'll get these files. This file is the base system image and this is the executable file. If you need to modify the code yourself or run it on the other board, you'll need to download the source and compile it yourself. Here we provide the download commands. First, you need to download the K230 toolchain. The download links are provided here. There are two toolchains. One is the Xuantie toolchain. The other is the Ruyi SDK toolchain. The download links are also provided here. I'll share these PowerPoint slides later. You can just follow these commands step by step. One very important point to note is, when running make at the final step, you will see the config option. You must select it accordingly to your board. For example, the 01 Studio board uses the 01D config. The Rusan Pi uses LCSDK LCKBF dconfig. This line must be added. Some packages need to be downloaded from our servers. With this link added, the compilation speed will be much faster. Here you can see that downloads and compilations are completed. I've compiled both versions here using different configs. I generated two different images. This is the official firmware after download. To enable Xiaozhi, we still need to make some modifications. First, modify the config. We need to enable boost and some WebSocket related configurations. On the Rusan Pi, we modify the config files. For 01 Studio, we modify this config file instead, and these lines. Let's take a look. Here it is already opened using VS Code. Then go to Config. You can see the Rusan Pi here. I have already added these config options. We also need to modify another config file according to the path above. The official tutorial instructs us to change it to CSI1 since the default is CSI2. We need to change the default to CSI. Here is the list of the required modification. First, modify the number of devices, then modify the DTS file. Change the previous I2C1 entry and continue using I2C1. Then modify the MIPI configuration. For example, if we use CSI1, we modify it accordingly. If we want to switch to CSI0, we can modify it here as well. One thing to note is, I'm using the GC2093 camera, so we may need to modify the camera's I2C address. Currently, we support two versions. One uses address
hex7e.
The other uses hex37. So we need to verify which address is being used. After modifying it, Use these two commands to rebuild, then run make. This will generate the image we need. After building the base image, we then compile Xiaozhi. The Xiaozhi code has also been open sourced. The repository and build instructions are provided here. Just git clone it. Let's take a look. You can see I have already downloaded it. After downloading, once the base image is built, run build.sh. This will rebuild the Xiaozhi application. One more thing to note, the screen rotation differs between boards. The 01 Studio board uses 270 degrees, while Rusan Pi uses 90 degrees. And so you need to modify the configuration accordingly. First, flash the firmware. Since we already have official tutorials for this, I won't repeat them here. Second, connect the serial port. I've already connected it here. Just type root and press enter. The program will start running. Let's check the network. I'm using a wired Ethernet, so it connects automatically after boot. We also need to make sure the board and the PC are on the same subnet. Let's check. The board's IP address is 1.108. First, confirm that the PC and the boards are on the same subnet. Here I can see the board's IP address. I'll try to ping it from the PC. You can see the ping is successful. That means both devices are on the same subnet. Next, we copy the binary files to the board. Here we can run the scp command. You can see the copy is completed. Now, on the board, let's check. You can see the file has been copied over. Now unzip it. I have already unzipped it. Enter the directory and add execution permissions to the file. You can see they are now executable. Next, confirm that the screen display is working. The Rusan Pi only supports this LCD screen, so it displays automatically after boot. We can verify this. Run vglight_cube command. You will see a rotating square on the screen. For the 01 board, you will need to copy the LCD DTV file over. For the 01 board, you need to rename the LCD DTV file to a K.dtb file. After sync and rebooting, it will work accordingly. We also need to confirm that the camera works. Use this command to check. At this point, you can see the camera has started running. If this step fails, check the I2C address as mentioned earlier. Use a command to confirm which camera address is used. The I2C address is hex 37, so this address should be set to 37. Currently, the official default also uses address 37. If you use hex 7e, you need to recompile the SDK. Once the displays and camera are confirmed to work, we can run the Xiaozhi program. You can see the applications is now running correctly. Xiaozhi, tell a joke today or play a song. Tell a joke. Okay, you can see it is running normally. If the device is not activated, the screen will display device not activated, and the serial console will print an activation code. At this point, you need to open this page. You can go to this website to activate the device. Enter the console. Here, you need to register. After registration, just add a device and enter the activation code. Simple. It is like redeeming rewards in a game. Just enter the code. To stop the application, run stop.sh. Okay, that's it. The application has stopped. That's all for today's sharing. Thank you for listening. Thank you.